Hello, in this video we're going to discuss iterators. So, there are five major types of iterators. There's an output iterator, which writes forward, an input iterator, which reads forward once, a forward iterator, which is good for like a forward list or unordered containers, which we haven't gotten to yet. Bi-Directional Iterator, you can read forward and backwards, good for list, set, other things that we probably won't cover all of these in this course. And a random access iterator, useful for arrays, vectors, decks, all sorts of fun stuff. So, an output iterator, let's take an example of that. If we indirect the pointer and set it to a value, it writes a value where the iterator refers. An iterator is like a smart pointer. You should think of it that way. Plus plus will step forward in the iterator and return a new position. Same with the iterator plus plus will return the old position. And there's a type you can do a copy constructor for an iterator as well. So let's take a very simple example. Here we include iterator, and we define our vector. And for each item in our vector, we push I times 10 into the back. Then we define our iterator, an O-stream iterator, out, IT is what we'll call it, and we're going to make it reference count and have it output a comma following each item. Then we're going to take our vector and copy it into the copy the values from the vector into the iterator, which will cause the iterator to execute. And it will execute this particular piece of code, and it will then output it like this. An input iterator does something somewhat similar. Well, not really similar, but similar in the reverse direction. So we're going to get an end of stream iterator, and then a standard in iterator, and if IIT doesn't if our standard in iterator doesn't equal the end of stream, we're going to grab its value into value 1. And we're going to go to the next one and similarly grab value 2. Now, what we do here, we count value 1 and value 2, value 1 times value 2, and basically it will step along and receive the information. So now we're going to talk briefly about the forward iterator. We've seen this one before. Basically, we set up a forward our list, then we use auto. Auto determines the type of the variable, and we start at the begin, and until it doesn't equal, while it doesn't equal end, we go through and increment it, and here we're going to output the contents of the array, and then find a new line, and here's what we will get. Now we're going to discuss a bidirectional iterator, similar to a forward iterator, but minus steps backwards, etc. So basically, we define our array of integers. We're going to create a second list of integers now, and we're going to iterate through foo and insert it to bar. Basically, grab the value from foo by using just the forward iterator and put it into bar. Now we want to iterate through and print the contents, and we use a forward iterator. Now we want to use it reversed, and it's basically the same exact thing, except that we start at the end and use the double minus and double minus, and we go back to begin. This time we look for beginning. This is very ugly, and it's only for the demonstration purposes. And then we have the random access iterator. It lets us access an element at index n. We can move n forward, back. You can return the iterator at the nth next element. returns the distance between iterator 1 or 2, returns whether iterator 1 is before iterator 2 in the list, iterator 1 is after, and before or equal, or not, whether iterator 1 is not after iterator 2, and whether iterator 1 is not before item 2. So here's our example. Basically, we're going to push all these items onto our list, and we're going to move forward 5, and then we're going to move back 2 and print out. So we'll get brown, which is our 5th position, and then we'll move back to 3, which will give us gray. So after that, all that, let's discuss what an iterator is. An iterator is any object that, pointing to some element in a range of elements, such as an array or container, has the ability to iterate through the elements of that range using a set of operators with at least the double plus, increment, and dereference operators supplied. It basically represents a position in a container, and a pointer is a form of iterator. Iterators must be implemented on a per-class basis because the iterator does need to know how a class is implemented. Thus, iterators are always tied to a specific container class. Each STL container defines what iterators it can return. Instead of operating on specific types, algorithms are defined to operate on a range specified by a type of iterator. Each algorithm specifies what class of iterator it requires. Iterators can be generated by STL container functions, such as begin and end. All STL containers, but not the adapters, provide at least 2 types of iterators. Every container contains an iterator, a read-write iterator. A const iterator prevents the iterator from modifying the elements of container declared as constant. Every container contains a const iterator and this is a read-only iterator. So, as we said before, there are 5 classes: input, output, forward, bidirectional, and random. Input iterators read data from an input stream. They step forward element by element, return values element by element, and the input iterators can read elements only once. They can't go backwards. So here we decline 1 and go through for it. We can get access to the element, we get access to a member, move forward returns the old position, compare 2 iterators, and for equal and not equal. Out iterators write data to an output stream, step forward element by element. As with input iterators, you can't use an output iterator to iterate twice over the same range. And so here a copy iterator would be an example, and an output iterator for the result. Similarly, we have the same operations. Forward iterators combine the functionality of input and output. Unlike input and output iterators, forward iterators can refer to the same element in the same collection and process the same element more than once. It can be used in multi-pass algorithms. So binary search would take a forward iterator, for example. Operations, pretty much the same as the others. And bidirectional allows algorithms to pass through the elements forward and backwards. Operations defined for forward iterators applicable to bidirectional iterators. This type of iterator can be used with the sequence and associative containers, and there are additional operators, particularly the minus operator. Random access iterators, randomly processed container elements, can be used with containers of type vector, dec, string, and arrays. Operations defined for bidirectional iterators are applicable to random access iterators as well. So here's all the things you can perform on it, and they should all look familiar, except for the plus, equals, and etc. And here's how just a table to show you the different types. Input and output iterators are the most limited types. Forward, bidirectional, and random are also valid input iterators. This arrangement means that a template function which expects a bidirectional iterator can be provided with a random access iterator, but never with a forward iterator, because they're not interchangeable. To write generic code, you should use not equal rather than less than. The following loop works with any container. Begin doesn't equal end, and increment. Operator less than is only provided for random access iterators, so it doesn't work with lists, sets, and maps. The following does not work with all containers. The copy algorithm is an algorithm that is provided by STL. It takes an input iterator for the first, an input iterator for the last, and an output iterator to preserve the results. Copies the elements in the range first to last non-inclusive into the range beginning at result. Copy assumes that the destination already has room for the elements being copied. It would be an error to copy into an empty list or vector. However, this is easily overcome with input operators. This is contained in the header file algorithm. Copy begin, and here's begin plus 1. And if we run the results, we will see output 0, 1, and 2. So there are predefined iterators. There's a reverse iterator, which operates in reverse. Insert iterators allow algorithms to perform insert mode rather than overwrite mode. Stream iterators to read and write to I/O streams. And here's some details on more. Reverse iterator is used to iterate through the elements of a container in reverse. Const reverse iterator is read-only, and to obtain a reverse iterator, we use our begin and our end, unlike begin and end. Our end is the reference to the position before the first element, and our begin is reference to the last element, just like how begin and end work, but in reverse. So we can do the same thing we did before, but this time we copy with from the reverse from begin to end. And if we run through with the loops, we get slightly different results than we did before, but then we can turn around and go through it again in the forward direction. Insert iterators let you point to some location in the container and insert elements. Insert iterators are special output operators designed to allow algorithms that overwrite elements to instead insert new elements. The container needs to have an insert member function. Whether value goes before or after depends on what kind of insert operator you've created. Many algorithms write to a destination which is assumed to have enough spots. You need to make sure there's enough space in your container. Insert operators let the destination container grow accordingly. You can create an insert operator with the back inserter operator, which appends by pushback. It applies to any list type structure. A front inserter does the same at the front. Doesn't apply to a vector because that causes everything to shift. An inserter inserts at iterator position in the same order by insert. So here's an example of all three. We say back inserter, and we do our copy, and then we get our results in the order we're expecting from the back inserter. Everything gets pushed on the back. The front inserter pushes everything on the front, so it acts more like a stack. And the inserter inserts at the appropriate position we say we're going to insert at the beginning. So stream iterators are used to input data into a program from an input stream, and they can and iStream iterator contains destination on input stream iterator. These are input iterators, and the syntax is identifier. So we create an iStream iterator, and then first we create our iterator, copy iterator from in. We create our iStream iterator, and then we create our back inserter iterator, and now we run through it. And the first argument to copy calls an iStream iterator that simply points to the input stream CN. The second argument calls a special constructor that creates a pointer to the end of the input. What this means is, especially for terminal input, depending on your operating system, is dependent on your OS. So read all the words from standard input and save into the vector. Here's a quick way to do it instead of doing it using the good old-fashioned input. So we similarly have one output. It contains a definition of an output stream. Okay, so we would say outstream identifier. Here's an example. We define our identifier, outstream, and what the output looks like, which means put a space between each, and then copy everything using our iterator. A pair treats two values as a single unit, and it's a struct type. It's found in utility. All members are public, first and second. We've got pair type 1, type 2, name it pair. So, and there's a make pair function as well, which takes two values. Constructs a pair object with its first element set to X and second to Y. Sounds like a basic constructor, but we don't use it because it's a struct. So here we create a light bulb. We say we got first a string and a double. We set the values. We copy it from another one. So we can have two iterators paired. And it compares the elements in the first range with those in the element range, and returns a pair of iterators to the first elements in each range that doesn't match. Okay? And here's that example. Equal range returns the bounds of the subrange that includes all the elements of the range with values equivalent to that. So we run through, return a pair of objects whose member pair first is an iterator to the lower bound, and pair second is its upper bound. So here we have this iterator, and we sort it, so we get a sorted array, and we get the bounds at the first position, and return bounds is a range that has two, or a pair that has a begin and an end for the lower bound and upper bound of the range, and it will output as follows. Distance returns the distance between two iterators. Here's a quick code example for that. And there are other iterators. We can use the fill algorithm to iterate from first to last and fill it in with a value. Fill in assigns a value to n elements of the sequence. Generate n, and so forth. So now we can use an example. We fill the vector with the first 4 items with 5, and we fill this other vector with starting at begin plus 3 to n minus 2, and fill it with 8. So now we get that. So forth. Here's another example. And here's generate. Generates a unique number, which makes it where you can't have duplicates. And here's an example of equal used to determine if the sequence is or is not equal. Woo, that was a lot to take in, huh? Iterators are very powerful and very usable. You should try all sorts of different combinations, and they give you expressive power in building algorithms. That's quite helpful.